Hello, good day to you all. Welcome back to SPE Live. Very glad that you are all joining us here today. We have another great show lined up for you today. I'm Nils Kaageson-Loe. It is my pleasure to be your host today. As we kick off, a big thank you to our sponsor, SPE Foundation, whose sponsorship makes SPE Live partly possible. Today, SPE Live is going to take a long look at drilling automation, the advances and impact it is having on operations in upstream oil and gas, and what the future holds. Industry is always looking for greater efficiency, lower cost, and ever safer working environments. The drilling floor is no exception. It's a particularly hazardous environment with heavy equipment, moving machinery, and high pressures in a relatively small space. So automation and robotics are a good thing. Viewers, audience, please tell us where you are watching from. I can see already we've got a lot of people saying hi to us, so thank you very much. Hi guys, good to see you all. Please send us your questions. Ask questions that you have about automation and drilling. Share your thoughts. This live stream is available on demand for free, as are all our other SPE Lives. So check it out and all our other SPE Lives on www.spe.org. You'll find us all there, or use hashtag SPE Live and you'll find more content. So joining me here today to answer the questions from you and to talk about drilling automation is Frode Jensen. He's joining us from a warm and sunny afternoon in Kristiansand in Norway. He is the Senior Vice President, Sales and Product Line at National Oil Well Vacuum. Frode has been with NOV for nearly 26 years, starting as a design engineer back in 1995, shortly after graduating from Norway's NTNU, Norwegian University of Science and Technology in Trondheim. He has held several influential leadership roles within NOV over the years, including Managing Director for NOV Norway, VP for Drilling Equipment Engineering, and VP Product Line Management. He is joined in our conversation today by Tony Pink. He is the Vice President of Wellbore Technologies at NOV. He is based in Houston and also very experienced, 28 years with NOV, spanning many leadership and technology roles, including advanced drilling solutions, automated drilling applications, and wellbore technologies. And early in his career, I found out he was also a directional driller. Tony is a graduate from Aberystwyth University in Wales, another leading engineering school in the UK. Gentlemen, welcome to you both. Great to see you.
Thank you, Nils.
Shortly. Yeah, there you go. Hi guys, there you all are. Yeah. And my dog is just joining in the conversation also. So thank you, dog. Between you, 54 years of experience, so looking forward to a really great discussion. Drilling automation, robotics and process automation, unstoppable innovation, many will argue, hopefully you will argue the same, bringing greater efficiency, lower costs, greater safety. So again, to our audience, please join our discussion, share your thoughts on automation, ask Tony and Frode questions. So let's dive straight in. Frode, perhaps you can give us a brief history on where we've been over time with drilling automation. I think we have a graphic that we can use just to help illustrate.
Yeah, certainly, Nils. So going back to maybe the 1980s, where everything was direct control, you started getting some mechanical equipment. Going into the 90s, you get some integration of the different equipment, and also increasing the number of operations that is mechanized. And then going further into more, you have automated sequences, just part of the process being run in an auto pre-programmed sequence. And then as we move into the 2010s, we have more process control on the pipe handling side with our multi-machine control, making sure that the operator is no longer just controlling each machine, but he's controlling the whole process and keeping an eye on what's going on and determining the speed. And the automation system in the background takes care of the actual movements of all the machines and the coordination. And then moving on to the last 4 or 5 years, drilling automation with our system called Novos, where you automate the drilling sequences and combine them with the pipe handling as well. So add stand, for instance, to the drilling process when you have drilled down a stand or when you trip out. On the pictures here on the bottom, you see the multiple machines involved in this process, and just doing a tripping process, it could be up to 9 different machines that you need to control in a systematic manner. And in order to manage that in an efficient manner, automation has a lot to give, because then you don't have to think about controlling each movement of each machine at a time. So, and then we'll talk more about where the future goes after a bit later in the show, I guess.
Yeah, absolutely, Frode. Thank you. Can you sort of give so I have a quick question there. What kind of efficiency gains have you seen over those sort of 10, 15 years, just with those simple steps?
Yeah, it's on some places you see a lot of efficiency gains because of the rapidity. You get the same results every time. Let's say, especially on the normals when you're drilling. If you want to do a certain sequence, it's happening the same time every time, so you get the repeatability. And then when you configure the system, you optimize. Basically, you have your best practice every time. So what we've seen on the pipe handling side, we've seen all the way from 5%, but basically also all the way up to 25% performance increase. But of course, this is depending on the crew and depending on the machines are tuned and properly maintained. So it's in that range. And also, of course, when you're running manual, a lot of the crews can do tremendous speeds on a quite short time by taking more risk and maybe starting, maybe not following the complete procedure that they should have done. So, but when you automate it, you get the same process every time according to the operator or the driller's best practice, basically. So you get the consistency, but then also when you have tuned your machines properly, you get efficiency gains.
Yeah, I mean, those are sort of really notable comments there. Consistency and that performance increase, 5 to 25%, substantial in many cases, particularly when we used to have much higher day rates on the rigs. Tony, do you want to sort of add some comments in there as we sort of, please.
Yeah, absolutely, Neil. The other parallel journey. So if what Frode showed you is the top side story and the real big advances in mechanization to robotics to automation and the process control with Novos. The other journey that sort of started out of the DSATs group that formed in the SPE was the sort of petroleum engineering discipline part of it. So taking data from downhole tools, feeding it up hole, then processing that data, and then using applications to drive the rig in a automated fashion. Yeah, and that's sort of been a 10-year journey where today, if you combine what Frode showed you with high-speed data from downhole, advanced applications on the surface, that whole thing was actually recently pulled together in the North Sea, and the last well that was just drilled by a jackup in the UK sector. Just they blew their record away on that, and that was multi-machine control, process control, and high-speed downhole data all together. So and literally that record well was drilled a couple of weeks ago, and that kind of really shows how it's starting to all glue together. And obviously with what we've got happening in our industry and in the world at the moment is what's the next steps out there to being able to do it from land or from the accommodation and things like that. So.
Yeah, no, great. So perhaps based on those comments you were talking there about sort of that integration of the sort of subsurface and sort of topside operations, maybe give us some more color around that. I mean, let's talk about that digital ecosphere. I think we have a graphic on that. So that kind of sort of splits up the sort of, or shows how those different operations join together.
Yeah, absolutely. as you move the experts away from the rig, yeah, and we start to talk about things like, when was the last time any of us were on an aeroplane with a navigator? So why does the directional driller need to be on the rig floor? But if he's not going to be there, we have to take those advances that were in the aeronautical industry, in the airline business, and make sure that the data speed and quality coming up from downhole is sufficient to start to enable automation and remote operations. So what we've been doing recently is taking data from the bottom hole assembly, gathering all the LWD data, so automated geosteering can be done, and then kind of taking data all the way along the hole back to the surface. So if you can have all the data back to the surface, and you can now connect that data source. So let's give a really easy example. So if you now have the integrated data, a long hole, and you have a formation with a frac gradient that is a certain pressure, now rather than the driller going really, really cautiously to run in hole, the combination of the process controller plus the long string data means now that the drawworks can be automatically controlled to run in just at the speed where we don't damage the formation. So we're running in at the speed where the surge pressure is safe, but we're not being overly conservative and wasting a lot of time. Same thing with pulling out of the hole. And then as we slowly integrate more of the managed pressure drilling type data, I truly believe that we can drill our well significantly safer by using the integration of those downhole data points and the surface optimization process controllers. Yeah.
Oh,
and also to add to that, when you're streaming those data or make the back office support able to see the same as the driller sees on the rig, you can have an expert group in the back office for the operator to give advice if you run into difficulties or there's problem with the well. So it will allow you, and from a supplier point of view, we're able to log on and help them if they run into issues with our equipment or our software, so we can remotely support them and get them quicker up and drilling again. So there's multiple benefits of having the data available on demand, so to speak.
Yeah, absolutely. Completely agree with Frode that obviously we talked about a big crew change. For the last day, it's been and gone now. Yeah. So we're going to have to connect the remaining talent in our industry. A subsea engineer or a pressure engineer or someone that's going to have to be able to spread his knowledge out across his or her knowledge across a much wider area. So this connectivity and getting data. That's the other, the other pillar of automation is that if you haven't got the data at sufficient speed and quality, it's really hard to do. And we're going to have to get that data, and we can see some of the operators, starting to challenge the personnel on board type story. I was talking to Maersk a couple of years ago, and we were starting a project which was called "Give Us Back Our Beds." Every decade Maersk had built an extra floor of accommodation on the jackup, and it wasn't full of Maersk hands; it was full of everybody else out there. And so, how can we reduce those people? Because I think it's going to become a necessity and not a nice to have. That those people are just going to that talent's going to not exist in our industry. So we're going to have to do, one individual running multiple rigs at one time now.
Yeah, absolutely. And so now you're sort of talking about that role of like the directional driller now not sitting on the rig, but in the remote operations center. So, and it's all that integration of downhole data and surface data and surface process control as you're talking about. Just to go back to that record-breaking well you mentioned a moment ago, and you mentioned also that now the automated process controls allow you to run in hole and pull out of hole at optimized speeds so you don't damage the formation. Not only does that make drilling safer, but more efficient. You don't have to treat lost circulation and all those kind of problems. Are those the kind of efficiency gains you guys are seeing at the moment through this automated process control?
Yeah, and I think it's a good question, Nils, because when we started to drive automation out into the world, we had to have almost two stories. In the Western Hemisphere on land, and that's probably applicable to the Middle East land operations as well. It was drill faster and safer. Yeah. In the North Sea and deep water, it was drill safer and faster. And the subtle difference there, really was that all the automation applications that we were applying on land was to break rock as fast as we could. Otherwise, the economics didn't work. In the North Sea, not damaging the rock, not getting stuck, preventing the catastrophic things were more important, because a lot of the time the ROP was already at the maximum that the solids control system or some limitation in the rig's capabilities. So it became more a case of safer and faster. And if you got rid of those giant NPT events, then the economics were clearly there in the jackup, semi, and drillship world.
Yeah, absolutely. Frode, let's talk a little bit about some of the automation around some of the processes on the rig. So, for example, you guys mentioned MPD and UPD operations, but drilling fluid systems are a large part of that. I think we had a graphic somewhere that could show a little bit about the automation of that drilling fluid system management. Perhaps you can talk about that a bit.
Yeah, so basically all the way from the supply boat coming with the bulk, we have now automation system for aligning all the valves, starting the pumps for transferring the solids, and then once you have that in place, you move on to the mixing. So you can prescribe your mud prescription and dose it the way the cementing the mud company wants it to be. So you mix all your mud automatically for a certain density or a certain viscosity, and then you also measure that you actually have got those properties with having inline real-time measurement systems in place. And then you also measure that same properties when you send the mud into the well, and then when it's coming out of the well again, to make sure that you, let's say, normally optimize the viscosity so that you are able to get all the cuttings out of the well, so you minimize your sort of well circulation and well cleaning time, and that's also adding to the improved performance or reduced time for drilling the well. So we basically have a complete circle now where we have a closed loop system and able to see what's going in the well, what's coming out of the well, and this on the safety side is also able us to do early kick detections and look at the safety of the well itself. So yeah, so we also here adding a process automation layer on top of the existing control system for the mud and the mixing system. So repeatability and also consistency in the mud quality is what we're trying to achieve.
This is fantastic, Frode. I mean, to me, I'm an old mud engineer, so I look at this and sort of with amusement and happiness. You're automating a relatively complex system, yet a simple system, and we're going to talk a little bit later about sort of retrofitting and some of the challenges, but just mention it here. I mean, there's a lot of equipment here that needs to be automated or retrofitted. How difficult is that?
Yeah, so even if you, of course, if you want to go fully automated, it needs to be instrumented, all the valves and all the rest of it. But you do have an opportunity if you have manual valves that you actually do it, just open or close the valves manually, but the system tells you which valves to open and close. And you just you click confirm once you open and close that valve. And then the system mixes as much mud as you have prescribed to whatever properties. So even if you have limited automation on the valve side, you have the option of doing part of it. What you normally have to do is this item number I, the fluid property instrumentation skid, which is basically a small skid that can be retrofitted into the mud lines to measure the density, the properties, and other mud, what you need to know about the mud that you're getting, what you think you're getting, right? So instrumentation of valves, and adding the two skids going into the well and coming out. Yeah. Yeah. No, I can see. And then of course on the software, we're adding what we call doors process automation control system on top of the existing mud control system. Yeah. No, I can see that. That's it's very interesting, very intricate. I can also see some of the stumbling blocks and challenges. Now, Tony, you mentioned earlier that difference between land operations and offshore operations, drill faster and safer for land, drill safer and faster for offshore, particularly deep water. So that brings up the question of, the challenges around automation and particularly the retrofitting. And we had a question earlier from our Instagram audience around about the differences between offshore and onshore and retrofitting. Perhaps we can have that question now.
Yeah, I mean, I think the biggest challenge on land has been it's economics. Yeah, if you've got if you're going to put out a skid, an automated mud measurement skid, and that skid is more expensive than the mudman being there, then the skid has to be able to prove that the data that you gather from that skid is improving the quality of the mud, so that the well is being drilled more efficiently. We're getting better solids control. We're getting better cuttings transportation, and on land it won't survive. That business model won't survive by just removing the mudman. Yeah. So the most successful automated applications on land have been the performance-driven ones that were managing vibration, managing ROP, optimizing the input energy into the system. And so it was, a combination of process control and drilling optimization apps. We did have a number of successful projects with wired drill pipe in land, but in a lot of cases, what the customer did was use the wired drill pipe for a year, crack the secret source that from the data, and then built that into models that would then run with surface data. What we have seen, though, is we have seen in a lot of cases, and probably now as the competency of the organizations change, a fallback in performance. Yeah. So the one thing that high-speed downhole data gives you is it gives you confidence to make. It makes you can be confidently aggressive. Yeah. So a company man could have the data right in front of him and go, oh, increasing the RPM from 100 to 140. The wheels aren't going to come off the VHA. Actually, the vibrational environment has improved, and I'm drilling faster in a safe way. And I think we're going to lead in the conversation. This is what has slowed the adoption of automation down, and it's been change and culture. Yeah, and one of the things we saw when we were running wired drill pipe was it became successful. when we had the cultural change that the communication loop between the drilling engineer, the remote operation center, and the driller became the same speed as the data feed. So we basically had the equivalent of WhatsApp going between the remote operation center, the driller, and the company man and the drilling engineer, so that when they saw the problems at the speed that they do now, which is in minutes, you see the increase in vibration. The remote operation center guys can say, "Oh, we've got high stick slip, increase the RPM." The driller would go, "Yep, on it right away," and then the stick slip would go down, and the company man goes, "Oh, that was fantastic." And that process loop took 30 seconds. Yeah. If you don't have that communication process loop, it's much more difficult to do these ambitious things. Yeah.
Yeah. No. Well, let's dig a little bit deeper on that comms piece in a second. I just want to go quickly to an audience question to dig deeper on that retrofitting piece. Let's just go to
Zachary Evans from West Virginia here in the U.S. And the question I have is, it's easier to see the applications of drilling automation and high technology applications in larger scale projects like offshore or even high capital investment projects in land. But where do you see the role of drilling automation and comparable technology for more traditional lower cost operations? Where's the break-even point between efficiency and cost savings and execution for these projects that have relatively low overhead and capital budgets? Thanks.
Yeah, actually, what we've seen as one of our most successful customer here, they are actually operating in the land, US and Canadian market, and they are managing to get very high value out of operating with Novos. I think the key of what they have done is having internal champions that's really driving the performance, optimizing the Novo system that they are using to get that performance, so that they are actually able to charge additional day rates to the operators for those rigs working. And that seemed to be a good strategy for them, that they spend a lot of time training their crews, not giving them the opportunity to switch back to manual, because if you first open that door, first thing something happens, then you're never going to get there. You have to make your crews use them. So I would say on these repetitive land pad drilling wells, you get a lot performance gains by optimizing the configuration and running the same wells over and over again with Novos or other similar systems. So I don't think it's only going to work on high cost offshore rigs, and that's been shown we actually have more rigs running with Novos on land than offshore. So.
Yeah, completely agree with Frode. Yeah, a good process controller to get that consistency. So even the worst case scenario is every member of the crew becomes as good as the best member of the crew. So you see that flattening of the competency across the crew, and then that continuous learning process, rather than it coming out on a piece of paper saying that this is the new drilling roadmap. You load the roadmap into the process controller, and then that well by well continuous improvement process is driven in there. So that's definitely applicable to the Middle East, US land, Canada, the big land operations. And then the other is a couple of key applications, and the applications don't have to be overly complex, but they have to be very rugged and reliable. Yeah, and it's that trust that the app is giving the right decision, that when it believes it has high torsional vibration, that it increases the RPM in steps, and everyone understands what's going on there. Those are the ones that bring the big value on land. Drilling optimization apps, and the process control. And then I think following on from the mud thing, I think having that mud controls and MPD but not requiring extra people out there, having the MPD controls on the rig floor, having them so that the driller has the interface through the process controller, so that we don't need the bloke on the choke, yeah, and we don't need the expensive additional capital equipment, and we get down to, you know, managed pressure drilling being run by who should run it, which is the drill crew, yeah.
Yeah.
And we enable on land in US land and we enable the drill crew to have a broader set of roles, but without losing the efficiency of the system. Yeah.
Yeah, no, great point there, Tony.
Yeah.
We'll talk a little bit about the field crews in a minute. I just want to go back a little bit to what you were saying about drilling efficiency, particularly for land operations. Perhaps, you know, hole quality is a parameter that we could talk about. You know, land operations, particularly in the US, they tend to drill the wells very, very quickly and not really care about hole quality because they pass it on and somebody fracks the well. So, but there are issues, maybe hole quality impacts fracking, etc. So, can you say a little bit about improvements in hole quality with the automation processes that you guys have been developing?
I mean, yeah, I mean, some of it's, you know, we had a partnership. There's a whole group called Rapid, which is a partnership of, you know, Baker, Halliburton, a number of drilling contractors, a number of operators, and the University of Texas called Rapid, yeah. And they built a tortuosity application, yeah. And when you look at that, and you look at some US land wells, you really wonder that they've ever been able to drill to TD the amount of tortuosity. But what we're thinking about, Nils, is and where we're going is stitching the data from drilling with the data from fracking and completions and the data from production. Yeah, our customers are screaming out for a data set that their analysts can mine that is stitched together properly across all the processes. Today, you know, capturing data on land is relatively unsophisticated, but there's nothing compared to fracking and completions. Yeah, that, you know, some operations are still run out of tally books. Yeah, so to understand that wellbore quality and the impact of drilling processes on completion performance, we've got to have that universal data set where the customers analytics guys can mine that data efficiently. Yeah, today they spend all their time trying to clean up the data and merge it to be able to mine it. So difficult that they don't in the end do it. Yeah. So I think that's going to be, you know, the digitalization pathway along beside the automation pathway is they have to go arm in arm on this over the next 4 or 5 years to keep up with each other. Yeah.
Yeah, that part of that digital ecosphere you were talking about earlier.
Absolutely.
Frode,
Yeah.
do you have anything you want to add to that in terms of the differences between land and offshore?
Of course, the wells are much more expensive offshore, so they can put more emphasis on getting the right quality because it's going to produce more over time and produce longer. So we're seeing more emphasis on getting the right quality on the offshore wells, of course.
Do you want to touch on robotics, Frode, and the difference between offshore and onshore robotics?
Yeah, let's touch about that. So, most, at least the higher spec offshore rigs today, they do have a mechanized pipe handling system on board, but still with those systems, there is gaps. So there is, you know, building bottom hole assembly, removing thread protectors, doing doping, a lot of small tasks that you need people still on the drill floor, but the gaps are relatively small. So what we're looking into there is to have smaller drill floor robots that is filling those gaps and including those into the automation process. So now we do a bigger portion of that automation process as a complete loop. On land, many of these rigs, or most of them, don't have any pipe handling. It's fully manual. So they were working with robotics as well And there, the purpose of the robots is mainly to do the tripping, assisting on the tripping of pipe in and out. And we were supposed to do a live pilot on a rig now, actually. Unfortunately, number of rigs drilling in the US is less than 250 at the moment, so it's hard to get the kit on a rig. Luckily, we have our own R&D test of a full-scale land rig up in Navasota, Texas. So we're running there the robotic system to do fully automated pipe handling on a land rig. So we can quite easily get those land rig retrofitted with a robotic pipe handling system that will remove people from the drill floor and actually improve safety and hopefully performance as well. So that's in the works now, probably commercially available early next year.
Oh, that's great to hear. Thank you.
So then you basically take the land rigs quite a step up on the automation pipe handling side. And we already have them running with Novos on the drilling automation. So.
Yeah, I mean, that's going to be a big step forward for US land operations in particular, getting that additional cost reduction on operations. It's going to improve the efficiency. Now, we're having a lot of really great questions from the audience. I'm going to pick up two in particular. So one from Ricardo Boreas. He's wondering, is there a confusion between automation and remote operations? So you guys have been talking about that automation and the data-centric, data-heavy piece of automation, and then the remote operations. And then Nassar Al-Awami was asking about lessons learned from previous drilling operations and how to optimize the drilling program. So again, it comes back to comments you made earlier. So maybe we can just address those two comments now. Remote operation, who has the last say? Because, you have a bunch of guys in a center somewhere watching the operation. You even have the directional driller there. So who has the last word on an operation and what's going on?
Yeah, I think, and again, it's culture and liabilities and things like that. And remote operations is the final extension of automation. If we were briefly touching the directional driller story, that if the directional driller is now replaced by autopilot, but the pilot, so in our analogy, the driller is still responsible for the operation, so he's there, but he's now being aided by what is the equivalent of air traffic control. So the air traffic control is saying, this is where you need to go, doing the navigation component. And that could be directional drilling navigation or geosteering. And they're sending that out to the driller, and the driller and the company man on site still take ownership of the borehole position. When you take that to the automated level, they are then only monitoring a automated directional drilling app or that is doing its stuff, but the driller and the company man are still on location, are taking the commands from the remote operation center and implementing it. So the responsibility still lies out on the rig. And then, as everything that Frode and I have talked about is automating the machinery to enable that driller to do that job in a consistent way without being overloaded by tasks, where on a non-automated rig, he's really a glamorized crane driver. Whereas on a no-bot rig, he's actually put back to being a driller again because he can focus on the process of breaking rock and keeping the wells safe. Yeah. So.
And also part of the question was, how do you take the learnings from one well to the next one?
Yeah, exactly.
And within our Novos system, you can configure the different operations, how you want them to perform. So then that's basically your best practice. So then once you have optimized that for one well, that's your starting point for the next one. So.
Yeah, I just had a follow-up question to that. So going back to some earlier comments you made about performance increases and consistency and the rate of information that's arriving through the automation and through all the data sensors. So how do you ensure that you actually have the right rate of reaction to the data that you're receiving, because you'll see variations in data that you haven't seen before because the frequency of data is so much higher now. So how quickly do you react, or do you wait patiently? How do you tell the machines to wait patiently before they react? You know, how do you get that sort of closed loop control?
In building automated directional drilling, when I was doing it myself, one of the most important aspects was to do nothing sometimes. Yeah. So you drill from a very hard formation into a very soft formation and then back into a hard one. And it was actually important to not do anything when you went through that thin section of very soft stuff. Otherwise, you would just end up chasing your tail. Training an application to do that was incredibly complicated, yeah, because the app has to sort of learn that during going through these rock sections, I have to stop them and just let it go and wait 10, 15, 20, 30 seconds. And the tool face going in the wrong direction is actually okay. It'll come back, yeah. And that's a very tough process that, you start to look at complex AI and machine learning algorithms to do that, artistic bit of directional drilling. Yeah.
Sorry, my dog is just
I hope you're not going to get eaten.
He's ready for his walk.
Yeah, he is. Yeah, he's making complaints in the back here. Just again to pick up on that, I'm wondering. Now I've forgotten my question. So, Frode, do you have anything to add to that? Sorry.
No, I think maybe we go to some questions from the audience to cover.
Yeah, we had some great questions. So let's just quickly take some audience questions from social, and then we'll pick up some more audience questions.
How will drilling automation affect the role of field personnel?
Okay. Yeah.
I'll let Frode answer first. Yeah.
Good question.
Yeah.
So let's say the driller. So now he's not focusing anymore on controlling the individual machines and the movement of those machines. He's now focusing on the whole process. Am I doing the right speed? Am I getting the right feedback from the system? And being more a process controller and not focusing on how do I move this machine from A to B. So that's a big difference there. And then on the drill floor crew, I think it's the same because it's so important when you go automation to have all the equipment tuned and maintained properly. Otherwise, this automation sequence stops. But then, so I think on the guys on the floor, the maintenance guys will be pretty much the same, maybe even more important to keep the equipment tuned and up and running. And then we have additional tools that they will have to learn to use to do that advanced diagnostic, to tune the valves, to tune the systems that will actually enable them to do more of what the OEM is doing today. And then, of course, for the driller, the more advanced systems he gets, he needs to be able to take in that new technology and understand it. But then we also coming up with additional information feeds. We have this Aura system where we can actually present to the driller what's the most important information for him to be aware of at the moment and not being swamped and overwhelmed with all the information that is available, but have presented what's critical for him to focus on now.
Yeah, you mentioned the Aura system there. Maybe we can take a quick look at what that looks like now. We have a short video on the Aura system that you guys have developed. So let's just play that now. Maybe you can just talk us through it a little bit as to what we're seeing.
Yeah, the Aura system is could be for road operation, but in this case, it's more for presenting the right information available to the driller or the company man or the guys in back office. So you take information feeds. In this case, we are lucky and have a wire drill pipe. So we take that data feed, do analysis of it up on the rig, and present it to the driller in this information wall, or what we call Aura system, so that he will be presented with what's the most relevant information from what's going on downhole for the driller currently, by having very advanced visualizations. You also pull in feeds from your CCTV cameras, and how you can pull in the complete well plan, how far you have progressed in that well plan. So it gives you sort of the whole overview of what's going on the rig itself. And then you configure based on the operation. The information feed is configured to the user. So the company man will have one information feed, the driller will have another one. And you can pull in, like I said, third-party information if you have a Schlumberger or uptake or whoever have some monitoring. They don't have to have that on their own separate screen, but you pull in all these small screens into the big video wall to put it that way.
So a lot of information being presented now in one screen, making it very efficient to make decisions, and you can make decisions in a far more informed way.
Yeah.
So obviously this is going to impact other sort of field service workers. So, you know, what's the role of like the mud logger or the drilling fluid engineer going to look like, or even the directional engineer, directional driller going to look like in the future?
Yeah, and you know what we've seen, you know, I think we've seen with the COVID-19, you know, the change in our lifestyles. You know, we're the three of us today are here talking remotely from our, you know, all over the world. You know, if you can ask that, if you can question that role, you know, with an MWD DD crew, yeah. So if the tool becomes simple enough that it comes out to the rig site basically ready, that just we have to pull the, you know, battery control to turn it off, to turn it on, and then the driller or the AD screws it together. The surface acquisition system becomes generic, and that data can be fed because of step changes in LTE communications or broadband in the North Sea or whatever it is. Then, you know, one directional driller can run 5 rigs, and potentially one MWD hand can be out in the field looking after multiple rigs. So I think those field engineering jobs are going to become, I think they're still going to exist, but one person will be able to cover a lot more operations. Yeah. Mud engineering, if you measure all the data and you're doing that, then really it just needs to be, you know, a chemical company, you know, and that transition I believe is gonna, it's gonna have to occur, because I think a lot of those personnel, as we pick up again, which we always do, those personnel may not be rushing back to our industry to ramp up, so we're gonna have to do it anyway.
Yeah, it's an interesting dilemma you bring up there, is that, you know, a lot of these existing roles are going to transition out, they're going to disappear. So that means people are going to need to reskill, maybe retrain, but also it's going to make our operations far more cost efficient, right? So we have fewer people, makes it safer, there's fewer people. So being a bit like a sort of modern day pilot in an airplane, right? So we have more information. Let's look ahead to the future, you know, so, you know, what lies ahead of us in terms of further automation and further sort of process improvement?
Yeah, I think on the, like we have talked a bit about as well, there is a lot of manual work still going on the drill floor and other places. So closing out those gaps, get people out of harm's way, and then adding the robotics, and then integrating the robotics into the automated processes we have already. And then what we're doing now, first we are removing the driller from the drill floor, but keeping him still on the rig, but he can operate from, let's say, living quarter. You have camera systems to give him all the best views for what's going on below drill floor, above drill floor, and he operates from there. And then maybe next step is you put the driller onshore in an operational center if you have good enough bandwidth and have the feed. And then you only have a maintenance and support crew on the rig. So, but still, we do have to close some more of those still manual operations that is needed on the rig itself.
Yeah, no, great, absolutely.
So this combination of automation and robotization is going to come together to close that whole loop.
Yeah, I did see it coming up in a question. You know, the other gap that's there that we need to solve in a couple of gaps in the future. You know, in interoperability. Yeah, if we're going to do all this, you know, we need to be able to. People building high quality applications and programs need to be able to talk to the machines and deliver the value. You know, us NOV or Schlumberger, none of us on our own can do everything, but making sure that things communicate with each other. And you know, we're rather than driving a standard at the moment in NOV, what we're trying, where we're going more is universal translation. So building the software that if a third party wants to talk to from A to B to C, that we do that universal translation. If you try and set standards, I think what you unfortunately get is by the time the standard gets agreed on, WITSML as an example, it's almost out of date and behind, you know. So if we can keep up universal translation with the changing protocols in computer science, I think we'll be there. The other one is the gap that hasn't been closed has been the drilling program that is done, say on Landmark or Schlumberger software, and then is translated. You know, it is not translated today efficiently into a digital drill plan and then into digital procedures that could then be loaded into Novos. Yeah, so that back end of taking the petroleum engineers expertise and the drilling planning group and the geologists and tidying that into automated operations, that world has not been connected well at the moment, and some of it just maybe, you know, business model and cultural challenges, or, you know, some companies wanting to completely dominate the space rather than be collaborative. Yeah.
Yeah, it's an interesting point you bring up there, because essentially it's a relatively simple step to move that drill plan or wellbore plan into a digital environment and then share it. So yeah, it's still, as you say, a challenge. I just want to go back to sort of some of the difficulties and challenges around automation. We had a really good question from Philippe Hervé. How do we train drilling crew to be ready to drill by exception, to sort of step in when an automated system is unable to sort of cope or respond satisfactorily?
Simulation.
Yeah.
But yes. I'll let Frode add to it.
Today there is still quite a lot of manual operations you have to do. So to run the door work up and down, to drive the top type, I think it's going to take some time. Every operation is going to be just push. So it's not a problem now. It could be in the future, but like Tony's saying, we do have training simulators that we either have ourselves or we actually sell to the drilling contractors that they have either on site or on the rig or in their training facilities. So yeah. There you can switch between, do I want to train in fully automatic or do I want to train in manual operation? It's the same simulator. So.
But yeah, even you know, even in the very early days of automation or mechanization, you know, I remember when we had challenges with an iron roughneck, and you know, we had a big 9.5-inch collar that we had to make up with tongs, and the crew had not made up anything on that rig with tongs in so long they couldn't even find the tongs. By the time we found the tongs, I mean, it was a 5-hour process to rig up a set of tongs to make up one joint. Yeah, so yeah, we've got to think about that human component and you know, simulation that is very, very realistic. You know, well, we do it for well control, so we're going to have to do it for other operations and make people that are using NOV's Novos system and our multi-machine, they feel comfortable on land, and they recertify once every year or once every 6 months, so that they're ready, each time they go back out to the rig.
Yeah, no, very interesting. And I'm wondering if that sort of also addresses this other question we got from Jorge Martinez Lozano. He was talking about tripping operations, tight spots. Are the automated systems able to learn so that they can adjust when they detect tight spots? Or is that still something that a manual operator is going to have to sort of adjust in the drilling program?
No, the recent stuff that we're seeing is that both some of the stuff we've done, but some third parties as well, their applications built around their models, talking to NOV's controls, have slowed down the tripping speed prior to pulling into a stuck situation. Yeah, so it's getting there. But as our industry becomes a little bit less conservative, more technologically advanced, we'll bring in that AI and machine learning capability and build it into the stuff. But yeah, we're getting there. I think we're sometimes maligned by other industries doing a lot of automation, but when we brought those other industries in, when they suddenly looked at the challenges that we have to overcome, that we drill through a material that changes every inch. Yeah. So there is no uniformity in the material that we're drilling a hole through. Yeah. And all these, guys that were automating chemical plants and things like that went, oh, actually, you guys are doing quite a good job. Your business is not in that bad a shape. That we have a very, very variable environment. And in the end, the only thing we really control is lowering, turning, and pumping. Yeah. So, yeah.
You bring up a really good point there. I mean, the other big disadvantage we have is we don't see directly what we're doing, right? Because it's very, very remote from where we are. So, I just want to pick up another point you brought up earlier, the pair of you, redundancy. How much redundancy do you need to build into an automated drilling system?
I'll let Frode answer that. Yeah.
Yes, so normally on the critical system, we do have redundancy built in already. But I think what's really important is to have good diagnostic systems as well. So let's say if you lose a sensor or you have a valve that is sticking, you have the opportunity to discover that fault switches quickly and correct it, so you can continue the operation. So, but in most critical systems, it is redundancy already designed in. So.
Yeah, thank you. So the other question I have around that is, apart from redundancy, and Tony, you mentioned this earlier, the cultural change. Do you see a difference between companies that are able to adapt and others that are slower to adapt to automation and robotics?
Yeah, absolutely. Yeah, I mean, in the early days of rolling out closed loop downhole automation, we had one customer. I remember I did a presentation, and everybody from the drilling engineer to the CEO were in the room at the same time, because this company was about 40 people. And we rolled it out and ran it, within a week. Yeah. The group that could probably benefit the most from automation is deep water. And in deep water, their change management is very, very rigorous. Yeah. And that's created quite a slow ability to change and develop new stuff. Yeah. So yeah, I think that change management process. I think there was an article that came out. I think it was published by the SPE very, very recently, that a lot of these type of initiatives, both on digitalization and automation, the companies have been under-investing in the people with change management expertise in their organization. Yeah, we think we can throw all this stuff at people and then just adopt it. Yeah, and when we did that with the early automation, I think Frode mentioned it. That you end up the driller. His first reaction is, "Oh, I can beat the automated system." Yeah, because he's on the wrong metric. And then once the drilling contractor said, no, actually the metric is you using the system, the greater percentage of time we will reward you rather than beating the system, then there was a complete cultural switch. Yeah. So we really do undervalue change management. Yeah.
And really have those champions that is driving the crews on the rig. To teach them and push them.
Yeah.
So you mentioning champions, change management. So we had a great question from Elijah Diplomo about how do you incorporate upcoming young professionals, in terms of automation. So what are the kind of important skills they will need to pick up as they come into the industry?
I think a lot of the younger kids with the gamings and all that stuff, they will be much more receptive to controls and the information flow and how everything is presented. From our side, we have also, donated simulation to different universities and are working with them to also with our Novo system. We are giving out free licenses to universities so that the students can learn how to use it and configure and basically get used to what's going to be in the real life when they come out.
Yeah, I think what we've got to get to them is the knowledge that was locked in the previous generation or the 50-year-olds left in the business. Get that knowledge digitalized, and then let them feel confident and comfortable in doing things. Don't penalize the learning process, but in most cases we find that they've already changed, and the problem's not them. The problem's the dinosaurs in the industry that's saying, I can still I can make up pipe faster with a chain on a cat head. Bye, guys. Yeah.
Absolutely. Just had a great question come in from the audience here. Really, really strong question. How close are we to automating well control? This is from Yania Strong-Coit.
That is very close. Yeah. Very, very close. Technically, super easy. We just have to have vertical acceptance from operator, drilling contractor, equipment provider that they're comfortable with it doing, and we can step that in from it being semi-automated, as in the driller still says something, he still has to press a button to agree, and I think then culturally that pressing a button will go away, and the system will do it automatically. Nuclear power stations shut themselves down automatically, so I don't see why we can't do it on a drilling operation. Yeah, you want to add to that, Frode?
No, I think you're right, and certainly the first step will be the driller still initiating and controlling when it's going to be done and not. He'll get advice, but then he will be still in control for sure. But on that, there are some systems being tested already out there. So
yeah, I guess it goes back to that question of trust and change management, cultural change within organizations, and being able to rely and want to rely on automated systems. So really, I just want to kind of round us off here. We had a great question from Masoud Kodad. It's a hypothetical question. If you had two side-by-side drilling operations, one conventional, one fully automated, which one would win? So, really, what does the future hold for us? Is it a fully automated drilling rig with like just one or two people? What does that future look like for you guys?
So I think who would win? If you had the best crew on the manual rig, they'll probably be even. at least on the first shift. But then over time, because of the consistency, the automated will be quicker. But it's impossible to answer how much time saving. But over time, you get the consistency, you get the lessons learned feed into the system, and you don't have the variation between the crews. So.
Yeah, and the app doesn't need a coffee break or go to the smoke shack. Yeah. So it does. Certainly, we've seen consistently that the minimum win is that all four crews, all four drillers, everybody's the old dude teaches the young one how to use Novos that and they all catch up with each other. Then the young intuitive one who's more used to technology starts teaching the old one, and then and it just spirals upwards. Yeah. That it wouldn't do with a conventional crew, because one person would change out and a new person would come in and they would lose capability. So yeah, no, I exactly as Frode, a super duper top crew is going to match the automation system initially, but over time the automation will always win. Yeah.
Yeah, I think we've seen that in many other parallel industries, like the automotive industry, sort of construction of automobiles and production lines and other production line type things, where automation has gradually become more efficient. And
people don't realize that we talked when we started Novos, we talked to NASA and we talked to the airlines, and the airlines said one thing. They go, you probably don't know that the pilots fought autopilot for a decade. They refused to adopt it, and they would turn it off, and then we'd all go through massive turbulence, and they'd try and fly the plane halfway across the Atlantic on their own, and now it's it must be 98% usage on an airplane of autopilot. So yeah, those cultural barriers, what we're seeing is nothing different to what the airline industry did, but they're 30 years ahead of us. Yeah.
Yeah, but they can still see what they're flying through. We can't see what we drove through. So there's a slight difference there.
Yeah.
Gents, great talking today. Maybe just give us a final message. What is the future for automated drilling?
Come, Frode.
So I think it's going to be gradual improvements, closing the gaps we have now, and then there's not going to be a lot of rigs being built. So you have to upgrade what you have, or at least that's going to be the majority. So the new technology that comes out will have to be retrofittable so that you can get more out of your existing assets, and then gradually you'll take step by step and get more and more automation, robotization out of it. And you get value out of your existing assets.
All right, thanks. Tony, any last comments?
Yeah, collaborate. Yeah, I mean, none of us can do it on our own. Yeah. I think, that's a lesson I've learned in the last, particularly in the last 2 or 3 years, that there's so much talent out there in the world capable of building algorithms, building apps, doing stuff that if you partner, you will have exponential growth in this technology. If you try and do it all yourselves, then you're going to fall flat on your face. Yeah. So the more open companies are, at every level in our industry, the more open the operators are, the more open the contract. All of us open and open the system up. Whilst not devaluing your own business models, but you can open it up and enable others to play in the space. And NOV took that strategy. We've really helped a lot of people plug into our stuff, and I think that's the way forward, because all the smartest people are not in one company.
No, indeed, collaboration is extremely important, and considering how far we've come in the last 30, 40 years in drilling, I can only look forward with great happiness as to where we're going to go next in terms of how much more efficient, how much faster, and above all, safely we can drill wells. So to me, it's a very...
Yeah, with regard to safety, some of the things we're adding now is, of course, camera and LiDAR systems. So whenever there is people on the drill floor, you can include them, detect them, and include them in the anti-collision systems, for instance. So certainly one of the strongest focus is to keep the guys out there safe. So.
Absolutely, yeah. So to be able to dance around the moving equipment safely, yeah.
Absolutely. Yeah, and we have a future as a bunch of drillers, because somewhere down the road we'll be drilling for very hot water as well, and steam. Yeah, so the drilling industry is going to be healthy and robust. You know, even with renewables, we have an opportunity for a big chunk of renewables, which is harnessing the world's heat. Yeah, and those drilling challenges we haven't even scratched the surface on. We have to work out how we can drill through granite in Norway at 10, 20 meters an hour. Yeah. And we cannot do that. That is a major problem at the moment to get to hot rock. Yeah. So, you know, if we can drill at 20,000, you know, these deep water wells, and we can solve those problems, there's absolutely no reason we can't drill, you know, for steam and hot water, and drill horizontal wells deep enough to do that. And, you know, that's the new challenge for the drillers, is do that. Yeah.
And that's why we're a happy bunch of engineers, right?
Yeah, we
We've got these big problems to solve.
Problem, yeah, that's it. The only problem is all our tools melt at 175 C at the moment. So
one more to tick off later on.
Yeah,
gentlemen, been great talking to you. Thank you ever so much. It's been a really, really good hour conversation with you both, Frode and Tony. Thank you very much. And a big thank you to our SP Foundation, our sponsors as well. So thank you guys, and look forward to talking to you all again soon. Thank you. And thank you to our audience for participating. All right, thanks guys.
Bye, y'all. Yeah.